Support for Lab Out Loud is provided by NSTA, the National Science Teaching Association. Find out more about what NSTA has to offer at nsta.org. You're listening to Lab Out Loud, Science for the Classroom and Beyond. And today we're doing another Scientist Out Loud episode. Our guest today is going to share with us what her research is about and what she has learned throughout the process.
Even though I'd worked in a lab for a couple years in undergrad, I didn't understand the implications of being totally in charge of my own work, totally in charge of my own research. I think, even middle school, high school students can understand this when you, in your free time, decide that you want to do a certain project, whether you're learning to skateboard or you want to try cooking, you've watched British Bake Off and you want to bake a cake and all these different things. It can be really liberating to make your own rules and follow your own passions, but it also requires a lot of discipline.
That's up next on Lab Out Loud, but first I'm your co-host Dale Basler.
And I'm Brian Bartel.
And before we get into today's episode, let's talk about something that's coming up for next year. This being the last episode that's going to post of 2019, next year in 2020, which totally seemed like, do you remember like 2020 was like I know I've talked about this before.
It's far off. But yeah, now, you know what, I'm happy about this because I've struggled with like the aughts, like the aught 8, aught 9, and then the teens, back in 16. You can say
the 20s.
Yeah, but now that I feel like we've arrived to the actual, the decade proper, or the decades of the century proper.
Yeah, okay, yeah. But I still remember,
back in 2021
is that's like science fiction numbers. I don't know.
Well, I got together with some people the other day, and I was like, yeah, I graduated in 97, and I'm like doing the math. I'm like, that's over 20 years ago.
Exactly. Well, of course, there are going to be 2020 vision puns for the entire year, and NSTA is not alone in the fun. Coming up in Boston, there's going to be the national conference. It's going to run from April 2nd to the 5th of 2020. And guess what the theme is?
Vision?
2020 Science, Expanding the Vision. And they have
it had to have vision in it.
Heck yeah. So check out the conference. You can still get in for registration. There's early bird registration. And if you've never been to an NSTA conference, they are absolutely amazing. There's so much to see, learn, people to meet. And so it should be a great experience. April 2nd through the 5th. Check it out at NSTA's website for more details.
And we can't wait to see you there. We should be there again.
You bet. So we're doing another researcher, but before I have another announcement. We got some listener mail. We got some listener mail, and one of the questions was, do you provide transcripts for your podcasts? And we don't. We've done that in the past, but Brian and I both have day jobs, and typing up transcripts can be super time consuming. So we just don't have the time for that. But I thought this would be a good time to talk about where our podcast, you can find our podcast. So you can find our podcast at laboutloud.com. You can find our podcast where you find podcasts like Apple Podcasts, Spotify, the Google Podcasts or Google Music. Stitcher is one of them we push out to. But we also post our show to YouTube. And not a lot of people take advantage of it, but one of the reasons I put it in YouTube is it kind of does it automatically.
Yeah, they have the captioning that's built in.
Yeah, that's the thing. So if you're looking for transcripts or captioning, you can do that. You can find the show. Just search YouTube for Lab Out Loud, and you'll find the show there. And you can turn on the closed captioning, and YouTube does it automatically. So it's not perfect, but it's pretty darn good now.
I've been impressed by their output of that, and that's a great way for us to make it at least sort of accessible that way. So it's something we've thought about before, absolutely, and at least YouTube can do it for us.
Yeah, so pretty much wherever you want to find the show, we have pushed it out. If there is a place where you're like, I use this particular app for the podcast, leave us a comment, send us a message, contact us through social media, Twitter and Facebook, and let us know if there's some place you wish it would be so that you can use it. But I also found a Chrome extension for the Chrome browser, which will take the transcript in YouTube, the captions in YouTube and spit it out as a transcript. So I want to play with that, and I'll get that for the show notes for this episode if it works. I'll put it in the show notes. So watch for that. If it's
or a
there,
blog post or something like that.
If it's there, we'll kind of showcase that. But
well, fantastic.
Yeah, that's our little research about how we make our show and some of the things that we've learned through the process. But we have a guest who's going through some process of research right now.
That's right. So this is another episode of our Scientist Out Loud series. We've been off for a couple weeks on that. We were kind of doing every other episode, and we'll try to do that next year, starting January. And if you are a researcher or active scientist out in the field right now, or in a lab, I guess, if you would like to discuss your research with us, just give us a line, or drop us a line, give us a call, or connect with us somehow. And there is contact information in the website at laboutloud.com. And we're starting to book for next year and thinking of who we could have on the show in terms of expanding the Scientist Out Loud series. But today, we would like to welcome Susanna Harris to talk about her research.
Hey, I am Susanna Harris. I am a PhD candidate, or just a grad student, down at the University of North Carolina in Chapel Hill, and I study how bacteria stick to plant roots.
So no one's just a grad student. You say it that way, like, come on.
Yeah, I do get in trouble for that sometimes.
Okay. So where are you in your path here? What do you have left to do?
I am what is called ABD, which means all but dissertation. So I have been in grad school for almost 5 years now. And so I'm scheduled to graduate after about 5.5 years, which will be this May. So I'm very, very much looking forward to that.
Congratulations.
And shockingly, I definitely did not know this a long time ago, but 5.5 years is the average for biology-based PhDs. So I'm right on track. I always feel the need to justify that in some ways, but it's been a really cool process, and I'm finally at the point where I'm ready to get out and do other things, but also realizing that I'm going to be missing a lot of it too.
I think about like students that might listen to the show or teachers that play it for students. They might hear PhD and say, wow, that seems like, a different country to reach for them. I'm always curious at how you got to that path. Was it something you always set out to do, or did it just kind of life just bring you there?
It was a little bit of both. So I grew up really just loving science and kind of finding my way about which topic of science I liked. And in probably about middle school, I realized I enjoyed biology, or I liked just looking around and understanding the living parts of the world, and going to the ocean and looking in tide pools, or even just looking at different bugs and wondering how they were related or how they lived. And then there was a very specific time in my AP biology class, so advanced placement bio, and we had probably 2 days where we talked about bacteria and viruses and how they're all over the world. They're covering us. They're covering every single thing we see. And they're so important for every daily life activity. And I was just like, that is the coolest thing I have ever heard of. And so at that point, that was middle of my junior year. And so I went to college at the University of Iowa for my undergrad for a bachelor's in science for microbiology. And then I got a minor in Spanish. And at the time, all I knew is that I loved microbiology. I thought it was super cool. I wanted to understand it more. And it was only a couple years into my undergraduate where I even understood that a PhD was an option, or what that looked like, and realized that, I didn't have to get a microbiology degree to go into a specific type of job. I could actually, the next job I could do would be grad school, where I get paid to study and to read. And it's not anything like undergrad where you've got classes and things like that. It's really independent work where you're surrounded by a university who's helping you ask whatever questions you're interested in.
Sure. Now, you said in middle school that you kind of got the bug for this, which is interesting because we often hear that middle school is the age where kids start to turn off their love for science. Is there anything that you can pinpoint that is different about maybe your environment that allowed you to go the other way?
I think it has to do with that when I was in elementary school and things like that, I had this really broad interest in everything and I loved all parts of school. And it's sort of interesting because I think it was actually part of falling out of love with math that turned me towards science. Yeah. So I always really liked math problems in elementary school, and then in middle school, again, we all have these, as adults, we have these things that we look back and we're like, wow, that must have been a really powerful situation, because I still remember it, where I had a class that we would do these word problems, and then the people who got it right would be kind of called out in the class and being like, wow, this person got it again. And I found out that I didn't like that anymore. I didn't want people to know that I was good at math. But science for me was still so interesting, and it was still, you can be good at science in so many different ways, and it's not something that you're given a basic problem and you can really easily answer it. There's some memorization, but with math, it was working through. And until you're doing research, most of science is just this like amazing learning of understanding what's going on around you. So it was kind of for me a trade-off, which I think good and bad.
Yeah. Was it you didn't want others to know that you were good at math, or was it like you just started to not, see a passion with math?
I think it was a little of both. Okay. I think that, it started with me not wanting the attention about math, with me realizing, oh, this is not a, quote unquote cool thing to be able to do. And so I started turning more towards reading. I've always really loved reading, and that's a bit more of an isolated activity. It's something I could do on my own and without a lot of attention. But then as soon as I started losing the interest in being noticed, I think that I started to kind of pull away from wanting to do the math as much. It started to seem like, oh, this isn't something that I want to invest my time and energy into, because it might come back in a negative way. And it's funny, you get to the high school point, you're like, wow, I wish I had paid attention in middle school. And then get to college and you go, oh my gosh, I wish I had paid attention in high school. But I
was always the type, I struggled with math because pretty quickly there isn't a story, and then later when I was in college, and I became a physics teacher, and that always had like a narrative for the math. But in the math classes, it was always so...
Here's the problem.
Even if they tried to do a science problem, they were always sort of throwaway statements like, well, wait, in the end, they didn't really care. And it doesn't have to be that way, but that's what it was. But I do remember having students in my own physics classes they loved the puzzle part of math. They loved just the studying of the math part. And I had some college roommates too, where it was just like, they got that sense of awe and wonder from just the pure math, where I only got that awe from science.
Yeah, exactly. I think that's what really is cool about getting to go through the college process and get through the PhD process, is that, you find out that all of this stuff is really cool around the right people. I'm surrounded by people every single day who think microbiology is the coolest thing ever, and half of their brain is thinking about bacteria and viruses all the time. And we get together over coffee and just nerd out on how cool our work is.
Yes. Yeah. My daughter doesn't, she tells me she doesn't want to go to college. Sometimes I don't know if that's true or not, but she's 15, and she'll say that, but then she'll have these conversations, and they're not science, but they're like social issues and humanities, and just and it really took me back to the conversations I used to have in college with peers and that kind of situation. I'm like, are you sure you don't want to go to college? Because you're going to love it, because that is the time where you just are in an incubator of the mind. It's, so it's, and I could see why you want to stay in there too.
Absolutely. I think that's what's been the easy part of the transition to grad school is getting to stay with those people and with that kind of mindset.
So now you talked about how you felt like there were so many options with like learning science, and then biology, and then eventually microbiology, and then you whittled that down even further to what you're studying now. How did that process go? I mean, and I'm coming as a biology major too, and I remember we didn't have necessarily a focus, but I kind of gravitated towards the molecular biology side of things. But then when we'd be outside, people would be like, Brian, what's that bug? And I'm like, not my area, kind of a thing. Like, just because I'm a biology major doesn't mean every living thing is under my domain here. But could you describe your process of kind of like finding that whittling down of, finding your niche?
Ooh, I love the word niche in this conversation.
I know. I tried to like throw that in there for all the biology people.
Excellent pun.
Those of you playing the bingo at home.
So it was kind of a combination between having, good advisors and getting a chance to kind of look within myself and figure out, okay, what is getting me excited when I'm sitting down in a class? What is the part that I actually want to read? The little text block in my textbook, the little side note that is not going to be on the test, but you are just like, that's kind of cool. I want to read that.
Or sometimes it's on a test and you're like, thanks, professor.
Yeah, you're like, are you kidding? No one ever reads these. But a little bit of that, a little bit of the introspection side, and then quite a lot of just kind of going with the flow. I think that one of the things that's been difficult for me is I'm totally a planner. I want to know what my day looks like, what my week looks like. I want to know when I'm going to be done with something well in advance. And, like with biology, in life, there's been so many times where I've taken an unexpected turn and it's brought me to a place that I would have never even imagined I would enjoy. So my second year of college, I was looking to work in a research laboratory. And I think that's my biggest piece of advice to people who are interested in going into research or going into higher level science or, any kind of career, to find the time to actually put in hours towards whatever that job is going to look like. We all have ideas of what something is going to look like, and getting those hours, one, looks great on a resume. It's a really good talking point, especially in interviews, but also you get an idea of what that life would look like. So I was able to work in a lab. I was invited to be in a lab that studied soil microbiology, so different bacteria that lived in soil. And at the time, I wasn't very excited about it. I thought I wanted to work on human pathogens, so microbes, bacteria that make people sick, because I thought, well, that's really important. That's really relevant. I want to be excited about what I do because it's important. And the bacterium we were working on in this lab was basically, it's kind of boring from the outside perspective. It doesn't do that much for people. It doesn't really affect plants, but it had this super cool, interaction with itself and interaction with other microbes. And we just got to dig into that and understand these very intricate processes that were happening in these microbes. And the cool thing about biology is anything you learn in one system or one setting could be so important in other systems and other settings. And the stuff that we learned there is important in human pathogens. And it's just kind of cool on its own. And so when I went to grad school, again, I thought, well, it's time to give that whole human pathogen thing another try. And it turned out the science I could do with dangerous bacteria was a little bit limited, of course, and for good reasons. But I was used to working in a lab where everything was pretty safe. And so I could walk in and have a really cool idea and just start testing it. Whereas if you're working with animals or if you're working with something that can make you really sick, there's just a lot more of that kind of preemptive thinking involved. And I absolutely love what I do. I get to have these weird new ideas. And if it's not too expensive, if it doesn't take too much time, I can just jump in, give it a try. And if something's cool, I get to go to my boss and make it a bigger part of my project.
Wow. So what are you digging into right now? What's your research all about?
Well, you got a second pun there because I study how bacteria stick to plant roots. So if I
didn't even try that one.
Wow, that's pretty good, Brian. Yeah.
Yeah, it's just we got one more, and then I think you win podcast.
Then I get a trifecta, right?
Yeah. So if I say probiotics, what do y'all think about?
Yogurt.
Yeah.
Yogurt.
Yeah. Jamie Lee Curtis, I think, is her name.
Oh.
Yeah. What is that? Activia.
Activia. Yeah. She doesn't do it anymore, I think. Yeah.
Oh, well, what a loss to yogurt.
Yeah.
So yes, so probiotics, we think of yogurt and we think that, eating yogurt is helpful for us. It helps regulate our digestion. It can help us take up other nutrients, just kind of stay healthy in general. And that's because of the bacteria that are living in yogurt. The probiotics themselves are the good bacteria, the ones that can help us rather than the pathogens that will come in and make us sick. And so these good bacteria, they live in our gut or our intestines, and they will help us take up vitamins and nutrients. They help us digest our food. They actually protect us from those pathogens, and they can affect our immune system all over our body. And what's really cool is that these helpful bacteria and the microbiomes they make up, so the collection of microbes in any given space, they are important not just for humans, but for pretty much any other host or larger organism. So plants take up most of their nutrients and water and things like that in the soil, and it turns out they have a microbiome on their roots. And the type of bacteria and how active they are and kind of the interactions that are happening there can change how big the plant grows or how much it's affected by different kinds of diseases. And that's what I study, is how these plant probiotics really can help the plant, and maybe how we could get them to stay with the plant for longer.
Okay. So if I'm the high school senior in the back of the class, why should I care about that?
It's fair. I mean, I can give you a couple of reasons. The reason we put on grants. So when we write a grant, we're basically saying, hey, give us money for this. It's really important. What we say there is that, who in the classroom has eaten today? Hopefully everyone. It's high school, so
yeah.
It depends on what time of the day it is,
yeah, exactly.
First hour,
yeah. But at some point, everyone should eat something today, and all of that food, whether originally or directly, it comes from plants. And we are facing, by the year 2050, we are going to be the human population is going to be exceeding the expected production of food. So that's pretty terrifying, right? We've got, within high schoolers' lifetimes easily, we're going to be facing a situation where we don't have the food to feed the people on the earth. And what's scary is that most of the approaches we have right now to increase food production is through things like antibiotics, through pesticides, through chemical fertilizers, and all of these things take either a lot of energy to produce. Creating nitrogen fertilizers it's called the Haber process. It's one of those things you learn 16 times because it's so important. It's super high pressure, high heat, and it takes a ton of energy, and it puts out, carbon emissions and things like that. Antibiotics and pesticides can really ruin the natural microbes, the natural, living creatures in any environment. And so if we're going to try to increase crop yield, increase the number of plants that we can actually get to produce food, we need to come up with alternatives that will be more sustainable. And we think that that's going to be microbes, because they're already living with the plant. We just kind of need to give them a nudge to double down and work a little bit harder.
Mm-hmm. So that's funny, because I think about this when I was teaching in the high school level and in high school biology, right after the concept of, niche and habitat and ecosystem, that kind of thing. We talked about carrying capacity, and a lot of the students would obviously ask, well, what's the carrying capacity of the earth? And I'm thinking, well, we probably have hit it in terms of humankind, and we've gone way above it. And a lot of students would then say, well, what happens when we can't sustain ourselves anymore? And, in my mind, I'm thinking, well, I think you're going to find out in our lifetime here. But, but at the same time, it was a call to arms to science. And I think these are things that we are going to have to look to science to help us solve.
Yeah. Well, and I work in something called basic research, which doesn't mean it's like really boring and easy. Basically, there's basic research and there's applied research. Where basic research, we're trying to understand how the world works. We're trying to kind of probe these things that happen in real life and understand, it would be as if you went to a dog park and tried to understand how dogs would bark at each other. Versus applied research, we're trying to find an answer to a specific question in terms of creating something or solving a problem. And in that case, with the dog park analogy, it would be more like putting one dog into a dog park and making it bark because you want to have the loudest dog in a dog park. Because, if you have the loudest dog, something good will happen. I don't know. But great thing, the other reason I think that my project is awesome, not just because it's going to be helpful directly, but the stuff that we learn about the plant microbiome, that could help us understand things like a coral reef microbiome. It could help us understand any different kind of microbiome, that even the things that live on our teeth, all of this work kind of carries back around to itself. And you just never know what questions you're really answering for the future.
I believe we call that pure science versus applied science in the textbook, if my memory serves. Yeah, pure science. I like that, though.
I like it.
Mm-hmm. All right. So how has your path been so far in grad school? Ups and downs, setbacks?
Yeah, I think a yes would be an understatement. Even though I'd worked in a lab for a couple years in undergrad, I didn't understand kind of the implications of being totally in charge of my own work, totally in charge of my own research. I think, even middle school, high school students can understand this when you, in your free time, decide that you want to do a certain project, whether you're learning to skateboard or you want to try cooking. You've watched British Bake Off and you want to bake a cake and all these different things. It can be really liberating to make your own rules and follow your own passions, but it also requires a lot of discipline. It requires you to be motivated to do these things, even when they're not fun. There were probably 2 years in there where I didn't really make much progress, and I'm really proud to say that I pushed through those times. But definitely through grad school, have realized the importance of being disciplined, also giving yourself a break, being able to say, hey, I'm not a superhuman. I can't do this twice as fast as anyone else. I need to take breaks. And then also just surrounding yourself with people who are really awesome, surrounding yourself with people who want you to be successful, are excited about what you're doing, and who you look to for advice and support and inspiration.
Are there things that work against that? Like, can it be competitive and then you feel compelled to overstretch yourself?
Definitely. There's it's sort of kind of referred to this as a toxic culture, basically meaning, toxic, that can mean a whole bunch of different things. But when you break it down, it's really that the environment that we're working in can work against us. There's only so many hours in the day that you can be productive, and then it starts working against you for the next day. And even a lot of the things we say in research can hurt people in terms of pushing them to do things that are just sort of impossible, pushing them to work 10, 12-hour days regularly and still go home and feel guilty that they're watching a television show or they're going out to eat with their friends, even though we know that there's no way they could possibly be productive. I think it depends on the institution. So part of the reason I came to UNC Chapel Hill is that it's a very collaborative institution. They want everyone to be successful, and people will work with other labs, they'll work with other students to try to kind of help each other get through the process. But a lot of the higher tier, the Ivy Leagues, are kind of known for pitting people against each other and using that sort of competition as kind of a push to do more, even if it might not necessarily mean doing better. But yeah. I think it's been good for me because I've learned that, that external pressure and even that internal voice that says, well, you could be doing more, is something that I have to really push back against and respect my own boundaries and respect my own process.
So some schools make it almost like a gauntlet.
Oh, yeah. Definitely.
It's interesting, though, because when you do that, then you're kind of definitely pigeonholing the type of people that are doing the research.
Yeah.
Yeah, and then that's in turn probably going to affect what research gets done and so on.
Mm-hmm. No, it's a big problem, and I do see it getting better. I really do. I think that we're increasing accessibility to different kinds of people. We're changing the conversations. It's funny because, we ended up being connected through Twitter, right? And I think social media is a great place where you might be in your lab and feeling as though you can't really relate to other people who are doing really well right now, or you don't want to admit that you're struggling or that something is just, not going right. but it's a little bit easier to talk to people on social media and just kind of say, hey, I'm having a rough day. None of my science is working, and have 40 other people say, oh, yep, me too.
Yeah. Well, it's funny, though, because like you said, we got connected on Twitter, and I followed a scientist that was kind of spurred off of a science fiction writer that I follow. And this led me down a path where someone shared out a bunch of people that you might want to follow on science Twitter. You were one of these people. And, I started following them immediately, and it was uplifting because, I've been kind of following a lot of teachers, which is great, but you get caught in a lot of news and some other things in your own world. And it was a different voice out there to follow. And it was kind of cool to see the struggles, but also the successes just in, daily form. I even think about something this last week where you had posted that, something didn't go well, but then the next day, oh, it's working, and I think you said, my science is working again. And it was just kind of like, yes, things get better over time, right?
Absolutely. And, it's going to be a 5.5-year process. And when you defend, you put together a PowerPoint slide set and you give a 1-hour presentation, and it somehow encompasses 5.5 years of work.
Wow.
And I think that, throughout the history of science, we look at people who are just incredible. Barbara McClintock with her jumping genes, Marie Curie with understanding radioactivity, Rosalind Franklin helping us understand DNA. Yeah. And, specifically picking out women there just because often they get overlooked. But we look at them and we say, wow, they did this amazing thing, and then forget that they had been doing science for decades, and in those decades, the majority of the time is just failure. It's just something goes wrong. My dad was a high school biology teacher for a while, and one of his favorite things to say was that the experiment always works, but you might not be doing the experiment you thought you were doing. So
that's a good life lesson. Totally.
Wow.
Yeah.
It's actually parenting also, I believe.
Yeah. No, sometimes the experiment that I think I'm doing is how do these different bacteria interact on the plant root? And instead, the experiment I'm doing is, what happens when your water has contamination in it? Or other bacteria, or what happens when you try to add bacteria to a dying plant, even before you know that it's dying? But it's been a process, and it's a whole lot of failure, but realizing that you're surrounded by other people going through that same process can be, like you said, very uplifting.
That's what's nice about science, though, because failure, those are results also.
Yeah, absolutely. And for me, I've been trying this new thing where usually people avoid the word failure, or they limit it to these really big events where you apply for a scholarship and you don't get it, and that's a failure. And I think that's true, but instead I've been trying to think of failure as when you intend to get to one place and then you don't get there. And so I have tens, if not hundreds of failures every day where I say, I'm going to get out of bed at 8 a.m. and I get up at 8:15 and I'm like, whoops, failed. And it actually, for me, makes it feel like those bigger failures, those things that really affect more than just that moment, maybe they don't seem quite as big of a deal. And so I think I've been trying to, instead of avoiding failure, just accept that there's so many times in every day where I thought I was going one place and I didn't go there. And then it's a lot easier for me to see that, the failures are just redirections. And that's what happened a lot in undergrad. Something kind of funny. The only class I have ever dropped because I was doing so badly was immunology, which my full program title is going to be, I'm going to have a PhD in microbiology and immunology.
So take that, immunology.
Yeah. Immunology is the study of how your immune system works. And it just wasn't fun for me, and I wasn't good at it. And I fought against it for a bit, and then I just sort of said, you know what? It's okay. I don't need to know every single thing about every topic in microbiology, and that's fine. I love what I study, so that's
there is that moment though where you dropping a class the first time seems so. I don't know, like jumping
This is
off
not
a cliff.
what I was taught to do.
Yeah,
Yes.
I remember.
Yeah.
I had a professor that kind of coached me into dropping the class. And then I retook it. It was just things were going on in my life, and then he's like, you can retake this class and get things in order. And I was like, oh, okay, and then sedimentology is a class I dropped mainly because I kind of realized I hated it. It just didn't connect with me. But it is it's scary the first time.
Oh, yeah. Yeah. I mean,
You had to discover all the layers in yourself, Dale.
yeah.
Oh,
Well,
I was stretching on that one.
Susanna,
That
I was
doesn't count.
wondering how, deep down, how hard Brian was thinking to get the third pun.
That's all I've been thinking about the rest of the time.
He's got a big note bulletin board with like red yarn, tying it all together.
That's how my mind works, Dale. You got me. Just thinking my whiteboard and yarn.
Well, of course, we're all thinking of that one specific meme right now. So,
Yeah.
What is it? Is it Always Sunny?
Yes,
Ooh,
yes. Always Sunny in Philadelphia, where they have the
Yeah.
whole. Yeah. Totally.
Well, Susanna, before we let you go, what word of advice? What kind of you have the ear of students and teachers in the public and post-secondary private school system. What would you like to leave with us?
My biggest piece of advice recently has been to take more advice than you think you need, but to be very picky about who you're taking advice from. We talked a little bit earlier before this conversation about grad school and the ups and downs and things like that. And there's like a million different ways to not do something. I like to find people who are whatever I'm needing advice for, who are successful in that specific thing, and ask for their advice on that. And so a friend that I have who's really good at writing, I would go to them and ask for writing advice. And I wouldn't go to another friend who maybe isn't that good at writing and have them say all the different ways I shouldn't be writing. But the friend who's really good at writing, they might not be that great at speaking. And so I should go to a different person for the speaking. And I think especially for high school students, there's so much input of advice. You're surrounded by people who have ideas, and, whether it's your teachers or your parents or the internet, you have to be the one to choose your own path, but it's totally cool to find guides along those paths. And just like in this actual, if you're finding a guide along a path, you want to find someone who has been down that path. You don't want to find someone who's a really good guide for a totally different forest. So I would say, it's so beneficial to have people around you that will help you navigate and help you make those decisions. But it's also okay to say thank you for your advice and not follow it if it isn't from the right messenger.
Excellent. Well, thank you so much for guiding us tonight. I think I said tonight and today together.
You said tonight and today.
Yeah.
So
but
we got what you meant.
that I want to play this for my kids now. I feel like, it's like that is good advice for them.
Thank you. Well, this has been awesome. Thank you so much for having me, and shout out to all of Twitter for somehow getting us connected. It's always a cool thing.
Excellent.
Oh, speaking of Twitter, if anyone has any questions for me, follow-ups or whatever, I'm very accessible on Twitter. The handle is Susanna, Susanna, the letter L, and Harris, Harris. I love talking with early researchers, and I have a soft spot for early scientists and teachers of all kinds.
All right. So the conversation will continue. Thank you so much again, Susanna.
Awesome. Thank you.
Thanks for listening to this episode of Lab Out Loud. If you'd like to learn more about some of the things discussed in this episode or previous episodes, you can find show notes at our website, laboutloud.com. If you have a guest idea or a future topic that you'd like to see on Lab Out Loud, go to our contact page and send us a message. Also, you can subscribe to Lab Out Loud on your favorite podcasting app, such as Apple Podcasts, Spotify, Stitcher, Google Play, or wherever you like to find podcasts. While you're there, leave us a review and rating. Your input helps others find our show. Thanks again for listening.